Okay, everybody. So this video is going to cover lesson 8.4, which is about exponential functions. So in your blue packet, make sure you've got that ready to go on page, at the top of page 2. Before I start in with that for this year, 2025, a couple of reminders here. We've got ISASP testing next week, so that's going to kind of mess around with our schedule just a little bit. So we're not really sure exactly what we're doing for the test yet. It'll be sometime next week, and I'll have more information for you on that hopefully tomorrow. If anybody's thinking about retaking the last quiz, you can absolutely do that, whether you were gone some days or you just needed some more time to relearn that and come in and work on it. That's great. I would look at either tomorrow or Friday as being some really good days to retake that, although you have longer than that. You can even use time during ISASP testing next week if that works out better for you. So let's go ahead and jump into this. Take a second there. If you need to pause the video, you can. Maybe pause the video for like 2 minutes to talk about or to think about what you remember for this, and then I'll go over it here. So hopefully you got a chance to try this on your own. If we were thinking about our x and y axis, remembering that this one is the x-axis going left to right, the y-axis going up and down, and then the origin is right in the middle there at 0, 0. And then for labeling our quadrants, we start here in the upper right-hand side and we go counterclockwise. So 1, 2, 3, and quadrant 4 down there. So let's jump into exponential functions. So we've got a function that looks like this: y equals 2 to the x power. So the difference here is from everything we've seen before, the x is actually in the exponent. Right? X is actually in the x. That's not how you spell exponent. X is actually in the exponent. That is new. We have not done that before. But the way this works is we are just taking different values for x and plugging it in. So starting right here in the middle, if I plug in 0 for x, that just means I'm going to have 2 to the 0 power. And we remember 2 to the 0 power is really 1. So I have the point 0, 1. If I'm plugging in x equals 1, I'm putting a 1 there. X equals 2, I'm putting a 2. X equals 3, I'm putting a 3. And the same thing with the negative numbers. I'm going to give you a second here, maybe pause the video again for like a minute to try to figure out what those values are. We've done this before, so see if you remember that, and then we'll go over it. Okay, so hopefully you got a chance here to try those out on your own and pause the video. So when I go through these, 2 to the first power is just 2. 2 to the second power, 2 times 2 is 4. And then 2 to the third power, remember, is 2 times 2 times 2. That's 8. Then when I have my negative exponents, we remember negative exponents just make fractions. So 2 to the negative 1 is just going to be 1 over 2. 2 to the negative 2 is 1 over 4. 2 to the negative 3, if you look at that, that's 8, so it's 1 over 8. And so when I make my coordinates here, 1, 2, 2, 4, 3, 8, and then on these I have the fractions. Negative 1, 1/2, negative 2, 1/4, negative 3, 1/8, just like that. Those are going to be my points. So I just used my function. I plugged in x's, get out y's, just like we've been doing all through Unit 5, just with a new function this time. Then I'm going to go ahead and graph these. So 0, 1 is right there. 1, 2, 2, 4, and 3, 8. Those are pretty easy. But now when we do our negatives, we get fractions. So negative 1, 1/2 is like halfway between 0 and 1. Negative 2, 1/4 is even smaller. And negative 3, 1/8 is even smaller. And so a couple of things that I want you to notice here are, first of all, is this function linear? And it is definitely not. If you were to connect these dots, you would see this is definitely not a linear function. This is what we call an exponential function. And so it kind of has this kind of J curve shape we'll talk about. The second thing I would ask you to look at here is that if you look at this x-axis, the graph never actually gets there. If we kept going down and dividing by 2 and dividing by 2, we'd have a 16th and a 32nd and a 64th. But it never gets to 0. And so what's going on there is we call the x-axis an asymptote. And all that means is that the graph gets really close. Graph gets really close, but never touches or never gets there. That's probably a better way to say it. It's going to get closer and closer and closer to that x-axis, but it is never actually going to get to the x-axis. That's something kind of interesting. And the last thing I want to notice here is that when we saw this y equals 2 to the x, that's what's happening each time. You see how I'm doubling it? I'm times 2, times 2, times 2. That's what's happening in our graph there. Sorry. So go ahead and look at this one now. And this one's got a fraction in it. So I'm definitely going to want you to use Desmos here. You maybe need to pull out your Chromebook. If you need to pause the video to get your Chromebooks out now, that'd be a good time to do it. We're going to do the same thing, though. We've got y equals 1/2 to the x. So I'm going to plug in my different x values here. And I want you to take a second and just try on Desmos typing those in. I'm going to just do the first one here, this 1/2 to the 0, because we all know that that is going to be 1. So when I type this in, I'm going to do parentheses, and then I'll use my fraction button to do 1, and then arrow down 2, arrow out, close my parentheses. Oops, close my parentheses. And then this button right here is my fraction, or my exponent button. So I'll press that. You saw my cursor go up a little bit, and then I can type the 0. And you see that gives you 1. If you type that in and you didn't get 1, you know something went wrong. From there, you can just go ahead and change that number to whatever you want it to be. And I'll have pause the video here and go ahead and fill those out. Okay, so hopefully you got a chance to fill those out on your own with the Chromebook. So this is not a surprise. And so when I graph these, -2, 4, -1, 2, 0, 1, 1, 1/2, 2, 1/4, and I'll graph them all here. There's my positive ones. There's my negative ones, and you can see my graph should look something like that. And so the same kind of thing happens, right? It's just a mirror image. Instead of on this graph where it went up from left to right, on this graph it's going down. And so we still have that situation where we've got an asymptote at the x-axis. And before we flip over the back, I just want you to think about where you've maybe seen some graphs like these before, where you've seen this graph that kind of goes up and up and up really fast, and this graph that kind of goes down and down and down, but then approaches 0. And so one place you'll see a graph that looks a lot like this is if you were to look up a graph of the human population. Recently, it has stopped being quite so exponential, and it has kind of started to do one of these, just kind of leveling off. But for the past, several hundred years, it has looked very, very much like that. And if you were to look for a graph that looks like this, a really good place to look at would be radioactive decay. If you look at how much radioactive stuff is left over time, the graph looks like this. It kind of drops really fast at first, but then levels out and never really gets to 0. So definitely some applications of this idea in the real world. Exponential functions show up everywhere. So let's go ahead and flip over here. On the back side, this slide right here is going to cover pretty much all the important stuff. Like everything you need is your actual notes. So make sure you got this really well down. The equation that we're going to use for this is y equals a times, and we'll use the parentheses to show times, b to the x. Okay. Our functions did not have an a there. So when you thought about like y equals 2 to the x, there was no a. Or when y equals 1/2, to the x, there was no a. And all that means is that the a there was really just 1. It's that hidden 1 that's going to be in everything. So x comma y is just a point on the graph. And a is our starting point, which another word for that would be the y-intercept. And so if you look back on your graphs here, I'll flip back in a second. Right there, since my a was 1, my starting point was at 1. And on this one, since a was really 1, my starting point is at 1. And then we've got B, and B kind of gets split up into 2 categories. B is our kind of what we call a growth or decay factor. So when B is greater than 1, we have what's called exponential growth, and the graph goes up from left to right. Either way, that point, by the way, is 0, comma a. And when B is less than 1, we have exponential decay. And it looks something like that. Never actually gets to 0. But we still have that point 0, comma a. So anytime b is bigger than 0, we're going to be growing. We're going to be like times 2, times 2, times 2, times 2, times 2. Anytime b is less than 1, we're going to be decaying, taking half and half and half and half and half. Smaller and smaller and smaller. Okay. On this one, I'm going to go ahead and do the first 2 here, and then I'll have you pause the video and try the next ones. On this one, we're pretty easy. Remember, we've got our a times b to the x. So a is the 3, the b is the 2, because it's 2 to the x. And since it's 2, we've got growth. On the second one, a little bit harder. This one doesn't have an a written in there, so it's really 1 times 3 to the x. So my a is 1, my b is 3, and it's still growth. So go ahead and pause that video, try those next 4, and then come on back and we'll talk about this. Sorry about that. Okay, on these next ones here, really hidden 1 there. So we got 1, 2/3, and that is decay because the 2/3 is less than 1. On this one, the 4.2 is my b, which means again a is 1, and that's growth. On this next one, my a is 3, and my b is the 1/10. Well, 1/10 is less than 1, so that's decay. And then on this one, the 0.2, that's my b. The a is just the 1 out front, and that is decay. Okay, the last thing we got here is a couple examples. So this one's a growth application. Maxwell makes a clever proposal to his mom for an allowance. He has $1 in his pocket and asks her to double that $1 on day 1. He then wants her to keep doubling it every day. So day 1, he doubled that $1 he started with. He's got 2. We're going to keep doubling. So 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 64. 128. And 256. If you've played, what's it called, 2048, you probably recognize those numbers. So when we are doing this, we come up with this equation. We've got a times b to the x. Our starting value here is just 1. We started with $1. And our b, since we are doubling it, is just 2. Just like the very first example we did. If we're doubling times 2 times 2 times 2, that's 2. So 1 times 2 to the x, you don't need to write that hidden 1. And then for our answers here, how much will we have after 15 days or 20 days, we're just going to go ahead and plug in our values for x. So after 15 days to the 15th power, after 20 days to the 20th power, And I'm going to guess most of you can't go that far in your doubling. So let's go ahead and use a calculator. So if I've got 1 times 2 to the 15th, that's 32,768. So after 15 days, he'd have $32,768. So that's the first 15 days. He got to $32,000. That's pretty good. Let's try after 20 days. And we got a lot bigger number here. So that is 1,048,576. So 1,048,576. So you can see what exponential equations really do. It doesn't take long until you get to some really, really, really big numbers. Those last 5 days, really did a lot. So from there, we've got exponential decay. So this time started with 100 grams and is doing half each time. So after 1 hour, you'd be down to 50. Half of that's 25. Half of that's 12.5. Half of that is 6.25. And our equation this time would be starting at 100, so that's our A value, 1/2 or 0.5 to the x. So when we type these in to the 8 and to the 24, we're going to see these get really small really fast. So to the 8th power, when I type this in, 100 times 0.5, 0.5 to the 8th, I get 0.39. And when I type it into the 28th, or 24th rather, so an entire day, I get this. If you remember, this is scientific notation. So scientific notation means we've moved that decimal place 6 spots to the left. And so what that really is 0.000059. Teeny tiny little amount, right? Because that exponential equation, we just keep having and having and having and having. It gets getting smaller and smaller and smaller. So at this point, if you've got time left, here's the kind of the jobs for the rest of the time. You might not have much if you've been pausing the video. I want you to start with the proficiency practice on page 4. You do need to do all of that because it specifically asks you questions about that in the CFU. After that, you can start the CFU. It is open for today. And then when you're done with the CFU, probably no one's getting done with that CFU today. But then you go back and do page 5 on the proficiency practice. You don't need to do page 5 until you are done with everything else because it's got some of the more advanced questions. If you can do page 4, you've got the basics of this. I'll be back tomorrow, and you can ask any questions you need to. I'll see you then.